That's right, we're here to tell you about Half-Life and Radioactive Dating, two very important feats in science for finding the age of stones and living creatures like dinosaurs.
Half-Life and Radioactive Dating!
So, I bet you're all wondering, what is Half-Life? Well, I'm here with John, Andy, and Esri to tell you just what that is. Half-Life is a game from 1996 made by Gabe Newell, and it looks like this. See, it's a first-person...
Zane, I think he's
what?
the game here.
Do you mean?
You're talking about the wrong thing.
Am I talking about the wrong Half-Life?
Alright, sorry about that. Now, let's talk about the right kind of half-life. Half-life is the time that it takes for a radioactive isotope to decay half of its original mass. Why is it losing its mass? Well, that's because it's trying to become stable. Basically, this means that the isotope, which is a chemical element having a different amount of neutrons than protons, which is why they are unstable, is losing mass with the intention of becoming stable, or, to simplify further, make itself happy. And why do elements need to be stable, you might ask? Because when elements are unstable, they are highly reactive. And when an element is highly reactive,
bad things should happen.
Like this! Woo! Science!
Stop right there, Teach! Now, let me tell you about radioactive dating. It's the calculation of the age of a substance by measuring the radioactive material it contains, or the amount of atomic fission that takes place within. Basically, it's looking at a rock, counting how many radioactive atoms it has compared to how many it should have, and making predictions as to its age. Half-Life plays a major role in radioactive dating, as you might have guessed, because comparing this video game to... wrong Half-Life. Because comparing Half-Life means that years can basically be measured to atomic mass. That makes sense, right? To demonstrate, here's an example with the assistance of a graph.
that the handsome and talented Esri made.
For example, if I found some dinosaur bones buried in a carbonic material, and the carbonic material was at its half-life, then if its half-life was, say, 30 million years old, then you would know that the fossil is at least 30 million years old. So, about that
graph that I totally made, and not John at all. So, this is my graph. Oh, and John told me to tell you guys that atoms decrease as time increases. Also, this is an example. It's almost as if it decays or something. Alright then, ladies and gentlemen, it's time that we do some review questions. I desperately hope that you manage to retain at least enough of this information to answer them correctly. If not, then I'm really sorry about the flashy video effects. It's like 1:30 in the morning right now. Gotta do something interesting to keep us alive. Alright, so our first question from John is, why do radioactive isotopes lose mass? Is it A, because they're too heavy, B, to become stable, or C, to gain a different charge? 12 hours on the clock starts now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Boy, those hours sure went by fast. If you missed this question, I have no words for you. Now, the correct answer was B, to become more stable. Now, for question number 2, also made by John. What is the name for an atom of an element with a different number of neutrons? Is it A, an isotope, B, an ion, or C, a radical? 12 seconds. The answer is A, an isotope. If you missed that one, Well, I don't quite hate you yet. Alright, and now the final question. Half-life is the time it takes an isotope to blank half of its mass. Is it A, share, B, decay, or C, gain? Well, 12 seconds and you'll find out.
And why do elements need to be stable, you might ask? Because when elements... Esri, come on! I don't know.
And the answer is B! Wow, I just want to thank you so much for playing. I hope that you really learned something about Half-Life and about radioactive dating. This has been me, John, Andy, and Zane. Thank you so much.